Okay, let's start. Hey everyone, welcome to this month's webinar. It's called The Best Test because it rhymes. Other than that, we'll talk about different test types and how to pick them because don't usually pick the right type of test to what we need. So we'll talk about how to evaluate different types of tests and what we can get from each. I'll show you also examples of tests, how they look like. But basically, we'll talk about what we're testing rather than. So thank you again for coming today. My name is Gil, trainer and a consultant about all things that help make software better. What we're talking about today comes directly from my workshops on, well, actually, all kinds of workshops, all kinds of testing, because these kind of things like weave themselves into that. I'm the author of the books, and let's dive into what we're going to do. I just want to remind you the things that I do, apart from workshops on API tests and web testing and unit testing, they also talk about not just how to write tests, but how to write good tests. So if you're interested in this kind of material, if your team has reached some kind of maturity that you want to upscale them, let me know. I hope I can help. So what is a test? Now, the thing is that we're going to talk about manual and non-manual tests today, automated tests. And the thing is that our choice of what test to write needs to come second after we actually thought about what we want to test. So we're after that point, we discussed different test cases and we decided what we want to test, what kind of scenario, what kind of flow. Now we have options. So the first part of this is what we call test planning, coming up with all kinds of test cases. And we're now at the thing that we don't talk about, but which is test design. What kind of test we're going to choose, how to set it up, and so on. Usually we have a lot of options. But the way we work, like our mind works, is like going back to what we know. So if I've had enough experience with unit tests, I'll probably go to the unit test. If all I'm done was API test, that would be my go-to. What helps here also is that usually, and if these are not my first tests, or these are the team's not first tests, what will happen is that we'll have some kind of platform or framework to run these tests. Usually unit tests is not like that, don't need to require any platform to do that, but longer paths of test do require that, and sometimes it's just cheaper to do the next one. A lot of the times it's like taking an existing test, just modifying it, and we're always looking at that, like how do we get from we don't have a test to it, we have a test, and usually that's the shortest path. Take something that works, modify it. And we're not thinking about what are the benefits, what are the challenges that we're going to have, because we're thinking about we want a running test. And that's cool. Yeah, we all want a running test, who doesn't? But we need to consider if these are the tests that are going to serve us for the next 5 years, if we're picking the right things. Apart from the right format of the tests, we also make within these kind of constraints the decision about tools. Like we're working with JUnit, so obviously the next tool is going to be JUnit as well. Why change that? And sometimes we probably need to look at if this is the right tool for the job, and we'll talk about that as well. The consideration that we're talking about is not just like writing the test, meaning reaching a point where a test runs and completes and passes, but also the lifetime of the test after that. And test means test plus code. So if the test fails somewhere in the future, I need to know that I'll probably need to debug it and find out what the problem is and fix it. And if we had other features that we're going to get in, we're going to add more tests for that. So we kind of need to think about the whole life cycle of what a test gives us. We usually don't. It's just thinking about like passing from no test to a passing test and then say bye-bye to this test. And that's cool. We also need to think about maintenance, maintainability. These are things that we usually hard for us to define, so we don't. We just throw names at them: maintainability, fragility, stability. Kind of know these things when they happen, but we don't want to wait for that, or maybe it's okay to go with that as long as we're thinking about this is what we're going to get if we're choosing these kind of tests. The usual things that you'll see in many teams that don't do unit tests, for example, and they have or developer tests completely, in which either an automation team or a QA team does the testing. The default is just add another end-to-end test, because that's what we're using to do. So that's obviously not the best solution, like all tests running end-to-end tests. And we'll talk about why. I want to give a shout out to JUnit. So JUnit is famous for being the first unit test, which was not. There was before that a Smalltalk test framework. And before that, there was no test framework, but we had fit and fitness, like HTML-based tests, like the other driven tests within HTML, which is kind of cool. And we had that before 97. And since then, like if you look at JUnit, like it's spread around, and they call all test frameworks XUnit because they kind of have the same features. It's still the basis of writing tests, like any test framework out there. Identify tests, run the tests, give a result, give a report. So we're still, this mechanism is still what we're doing. So when we're thinking about, is this a JUnit test? Yes, but it could be like a JUnit. For unit test, an integration test, an API test, everything that runs on this engine. So we're going to throw a lot of names here, but names are not, we kind of use them very inaccurately. So we might want to think about our language. And we're not just talking about a test framework. We're talking about, when talking about testing, we talk about mocking frameworks, assertion frameworks, the whole things, set of tools that we're talking about, we kind of carry from one place to another. Again, it doesn't have to be like that, but it's an option. Again, we feel probably easier with the things that we know, so we carry them around. So like I said, there are a lot of other tools that people build. Usually what happens is that above the level of usually open source frameworks and commercial tools, some of them, people will build their own platform or system to make tests easier. Like I said, unit tests do not really require that. When we go up to higher level tests, we do need to manage tests in some kind of organization, where to put data, or where to find it, how to symbolize data. So people bring their own tools to the party, and some of them are like technological stuff. If you look at component test, which we'll probably look at, I'll show you an example. In React, there are tools like testing libraries specifically for these kind of things. And there are system things like Postman, for example, is an thing that is trying to test an entire system, but has its own kind of deficiencies. We'll talk about that as well. So tools are not a problem. Most of us have seen the testing pyramid. It depends of when we saw it first. It depends. This really says how many flows it had. Usually it looks like this: an end-to-end test at the top, the unit test at the bottom, and then we have API component, stuff like that. And this model says basically how many tests you should have from any kind. So more unit tests than API tests, for example, and more API tests than UI tests. And the reason behind that is that Unit tests are usually easier, simpler, faster to write. They have lower setup, and they're easy to debug if something happened. That's why you should have more of them. The more you climb up to the tower, you'll get paths that you're testing, like end-to-end, for example, that are testing a lot of the code that you didn't write. If you think about it, how much code we actually write, what we actually run, it's going to be like 10 to 20% max. Most of what we run is not our code. So that means that if something breaks, chances are it's not in our code. And if a UI, an end-to-end test actually passes, great. If it breaks, then we're going to spend a lot of time understanding what happened there. Could be our code. Not saying that it can't be, but a lot of the time it's an integration issue, integration problem, multiple integration issues. This is fun. And you run it again, it passes, cool time. So the pyramid tells us that this is what we should have. I don't consider it a plan because some applications don't have a requirement for unit tests. For example, if you're writing a CRUD application, just like data, bring data, store data, there won't be any unit tests or no application logic, or maybe you will write tests for that, but it will always pass. So it doesn't really matter that and tests passing all the time is not a good thing. It erodes our trust in the tests. So it is okay to know about this. I don't consider it like a good plan to it. Everyone should have their own model, whether it's a triangle, a pyramid, or a diamond, or an amoeba. Don't care. You need to consider what's cool for you. But I do bring this up because it does talk about, or directly, about the paths that we take inside the code that we want to test. So I'll show you a couple of examples of how this looks like. So I took like a general system example. Yours may or may not look like this. It doesn't matter, you'll get the idea. When we're saying, well, in this kind of system, what is a unit test? Usually we're talking about things like that. These are the yellow squares here. So the yellow squares talk about like the pieces of client code or server code, sometimes database code. If you write stored procedures, something like that, and you want to check that this piece of code does exactly what you expect it to have. Remember, this is an expectation. So I wrote the code. I have an expectation of what needs to do. So if there's a bug in there, I'll probably test it with the bug inside it, which is not a good idea, but it's the best I can do. Piece of code, any piece of code, is merely a translation of the requirements through the design and architecture to low-level design to classes to code. So within any translation, it's going to be errors. And the idea about unit tests is like I'm testing my expectation of how this code should behave, what this function should actually retain. So just let's look at an example of a unit test. You know, a calculator can add 1 and 2. The interesting thing that we don't think about, but we should, but what you see here basically are the things that test frameworks do. They identify a test through its name, you can run it, they have assertions and report back to green or the bottom. And this is like all the small stuff. But let's go back to what is interesting here, and we don't think about it all the time, is that a unit test runs code in the process of the test framework. It loads a class into the test framework memory space and runs it there. That means that when we debug a test, it's easier to debug. We'll talk about different tests that are harder to debug. That also means that if the code creates threads or stuff like that, it becomes harder to debug. And the more complex it is to debug, it is more complex to test. And we may call this a unit test if we're testing this, but it requires some kind of better skill and experience to write good tests. Okay, let's get back to our. So that's a unit test. And usually when talking about two types of things that people understand exactly what it is, it's unit test and end-to-end test. And what is an end-to-end test? It starts at the client, and notice that I was diligent enough. Not just go through my code, but through the big boxes here. Then the big boxes are the code that we didn't write. It is the code that runs. For example, things that run in the client are maybe we're talking about browser, so JavaScript engine, the browser code, different libraries that the code uses. Then there's my code. And the same thing for the server. So the server runs a lot of things that we don't see in our code, like maybe gateway or load balancer, the web server itself. The handling of requests is done by the server, and the translation, for example, if I send something as a JSON body and the translation of that to serialized object, done by the server. And obviously the database. So when we say to someone end-to-end, they imagine this kind of thing, depending on their system. And obviously this is a longer path in the system. And like we said, every piece of it can break. But these are not the only things that are the only types of tests. There are partial paths as well. So we're talking about API tests. We usually think about this, like an API that starts at what the server exposes, go to the server code, and the database. It doesn't have to be, though. When we say API tests, we can test something like this. So without a database, just a mock database, where we're either mocking a request to the database or just using a mocking framework to mock the calls, this is still an API test. It is higher, it's much more condensed, and that means it's more precise and probably will not fail on connectivity issues. So we'd say, well, is that a better test than the one with the database? It depends, because this thing here, if it passes, it gives us an idea that the server plus server code plus database work okay correctly. This doesn't, because we're mocking the database. However, when this fails, we know the problem is here. When this fails, we don't know where the problem is. So this is like the balance that we need to do with all kinds of test types. Same with UI. We can do UI to the end or UI to a mock database. We can choose different paths. We don't have names for that, these kind of tests. But in our test design, we're kind of thinking, well, what is interesting for us to know when this test passes and when this test fails? And we're going to continue asking these questions. If we're living in a microservice world, we all are, but if you're actually developing stuff like that, we're going to talk about integration. So sometimes you'll have like a service test, like a single microservice that has its own database and its own logic, and we can test it in isolation. But then we want to know, well, how is this working with another microservice? Start calling it integration test, but we'll see that we don't have a real definition for that. So this might be an interesting thing to test, how these things are working together. Again, what we'll learn is that, well, when the test passes, well, one microservice calls another one correctly with the expected results. When it fails, where's the problem? We'll need to dig. And then there are contract tests that check that the contract is not changed, that it's not like functionality, like all our tests until now, but they check that the interfaces are still being used correctly on the borders of the system. This, again, is another piece of information that we'd like to know, especially when we're deploying all the time, we're changing versions all the time. If we're deploying client and server independently, we'd like to know that we haven't broken the contracts. And another type of test, which is not a functional test, like a load test, performance test. Here's a load test, for example. So basically what we're doing is running the same path of the code, but in different contexts, like 1,000 users, 1,000 requests, million requests per second, to see how our system handles that. And when it passes, it tells us, well, the system can support X users at the same time. Where it doesn't, we know that it doesn't, but we don't know what failed. We'll have to reproduce the problem, which is hard, because these tools create a very complex scenarios and contexts in which we want to reproduce and see what happened and read a lot of logs and deduce from that what happens and how to fix that, which is complex because life is complex and systems are complex. So we can talk about test in different aspects. And I chose to ask these questions. And so what we'll do is go through a couple of different tests and ask or answer what we know about these kind of aspects. And the first one, which is the most important to what we want, is the feedback cycle. How long do we get an answer when we run it? Obviously, unit tests run a lot quicker than other stuff, but this kind of aspect tells us not only how much fast do we get an answer, but it also tells us where to put the test, in which kind of group do we put this thing to run with. Because let's say we have a very quick test, runs like 1 millisecond, but if we put it with other tests that run like 500 milliseconds each, it doesn't matter how quickly it runs. So our test organization really impacts that. So we want quick feedback. We want as much as possible for all kinds of tests. But this kind of tells us or guides us in a way of how to organize our tests for a quick feedback. Second aspect is who writes the test. This could be like the developers themselves, the testers, someone in the middle, DevOps, automation engineers. When we're actually, why is that important? We'll talk about why in a second, but part of, let's say you're working in sprints and you have to have something done in 3 weeks. Part of the plan is what kind of tests we're going to do, who's going to write them. And in the buckets that we're going to say, well, you're going to write this kind of test, I'm going to write this kind of test. At the end, we have this feature covered with these 3 unit tests, 5 end-to-end tests, and 4 API tests. And people have different skills, and different tests give us different ways to work. So it really is important to say, well, who's going to write it? What do we learn on pass and fail? Like I said, a lot of it depends of what we're testing a path that consists of usually code, and we usually look at functionality, but that's not always the thing that we're looking for. Show you example. We already talked about load and performance stuff. But it's also important to say, well, if this one fails, what do we learn? How much work do we need to do? Because this leads us to the last 2 things. Stability. What can fail this test? And the more we run none of our code, a lot of things can fail this test. And that means that we'll probably be seeing of this test a lot. And so stability is something important. We need to understand what makes things stable and what are not. And the final one is how easy it is to debug. So obviously, unit tests are easier to debug. Different tests have different levels of that. We'll talk about that as well. So we'll start with the unit test. Like I said, the unit test pieces of code. They don't give us the confidence that the system works, but they do give us the idea that that our function of classes work the same, the way we envision that. And that's good. Like in our calculator, for example, switch back to our code here. I have a calculator. It looks like this. It has different functions. And I have something that tests the add function, something that tests the add to memory. These are unit tests that are small. Test the class, but not the entire class, maybe. And maybe even, let's look at the class again. Where is it? Here. So my class has a dependency on something else. So a test can mock this thing. I'm using Mockito here to mock the memory service. And that means that the test checks the functionality of my code in isolation of that thing. And the mocking is done within the calling on the function, so the function doesn't execute. So if this fails, I know that the problem is in the calculator class. And this is like the thing. Another thing I want to show you is a part of our testing world is this thing. Like, I have a method called get memory as JSON, and I can test. Let me show it. So this one just JSONify or stringifies the memory into something like this. And in our world, we'll probably want to test this thing as well, because sometimes a result returns in different format, and we can define what it is that is important for us. For example, I'm using JSON assert here, which disregards completely white space. Why? We don't want the test to fail on things that are not important for us because we're not sure how things are going to be returning, and spaces are not that important. So even at this point, we can define what is important, what is not important. Slides again. So a unit test obviously runs quickly. We're talking about hundreds and thousands within seconds and minutes. This is what we're talking about. Who writes them? The developers, not just because they're close to the code, but in order to use mocking correctly. In order to do the assertion of the JSON, they need some kind of understanding of how the code works to write the right asserts and the mocks. We have coupling between the tests and the code, and the people who do that, it's not like we're blaming them for that, but the developers are sitting on the code, so they can. It's easier for them to do that. What we're learning if something is working or not is the expected logic. Like I said, we're expecting things to work in a certain way. This is how we test them. Stability is very stable because we're removing dependencies as much as possible. The only thing that can break something is the code. And therefore, a unit that passes, we expect it to pass until somebody touches the code and changes functionality. Debuggability, yes, there is a word like that. It's very high, meaning we can put a debugger, put a breakpoint, and debug what's working. Integration tests are, it's not that they don't exist, but most of what we do are integrated tests because we're running code that integrates with something else. The thing is that my integration tests and your integration tests are not really the same because this is a very big bucket. We have all kinds of things, like if I, not you yet, if I run something within, I showed you an example with Java, if I run, for example, within Spring, if I'm using in JavaScript, for example, I'm writing something in React, I'm already integrating with it these libraries and runtimes. So when I'm testing something, it's something that is together. So if we find some better names for that, that's cool. But other than that, it's hard to know unless we actually look at the test and ask what it is testing to evaluate that. So I'm not going to do this like the general thing. I'm going to look at examples. I do want to mention, though, Mr. Reagan's here at Raspberry Verify, which is a test that we don't talk a lot usually, but it's very important because it's not a functional test. Verification tests are there to test that all the tests that we're going to run soon, functional tests, are okay to run. So they check that everything's installed correctly, deployed correctly, the right version of Java is there, or the server is running, and the database, we can talk to it. So if these things don't happen, if we don't check them, that means that our tests can fail just because the environment is not set up for that. So we want verification tests, and I'll show you an interesting one, because when in Java, in Spring, when you create a project with Spring Boot, you get this test, which is an empty one, which looks like it doesn't matter. But yeah, it is a real test. When you run it, you actually run Spring and checks that Spring can load everything. And if this doesn't work, there's not much point in running any other tests. So verification tests are things that we need to be aware of, and we probably want to use in order to learn if we're able to run the next test. So get here back to Mr. Reagan. Feedback is not that quick because usually it's not, we're trying to talk to other containers and see if things are working there and so on. It's not that quick, but that's not really a problem. It kind of saves us a lot of time if we get that, if we learn that environment is not set up, instead of waiting for the whole cycle to see every test like dropped. Who can write it? Both developers and testers, depending on the skill, but they're checking that an environment is really set up. Doesn't require like maybe not the programming language of the code itself. Could be something else. Could write in Java and write the scripts in Python. So you need automation, some kind of skill in automation, but you don't need access to the code. How stable it is? Well, it is sort of stable because it checks that things are set up correctly and they can fail on these things, so it's sort of stable. How debuggable it is? Very, very high. If you have different tests, JDK is here, this version. Server is running. Database is running. Database is set up correctly. It's very easy to debug because if you don't put everything in one test, it will tell you what the problem is and how to solve it. So I'm continuing with my Java quest before I move on to the other things, as an example of what Spring calls a Spring API test. So what happens is that when we're talking about APIs, we can usually, and this is what I'll show an example in a minute, is that you talk to them from the outside. You run the system and talk to the APIs. Spring and other frameworks as well, it's not just Java, allow you to run an in-memory server that loads the controller and exposes the API. And this allows you to debug because with the minute you're stepping outside the process, it's harder to debug. It's harder to, you have to like to do some kind of remote debugging attached to a process and stuff like that. It's harder to debug. Spring allows you to do these things in the same process. So it loads a web service inside the test process and exposes the API, and you talk with it with HTTP, and it answers, and it actually runs these things, but all in the same process. And this is very cool. I'll show you how it looks like. Like I said, you can find these things in many other languages and frameworks. So Spring just used something called mock MVC to do that. And you build something and you talk with it with APIs. You see, I don't set up either a server or a port. It just opens it up for me automatically. And I talk with an API, and I can check that the JSON that has returned. And it is completely like writing tests for APIs, but inside the box. So let's talk about what this one gives me. So it is a slower test, slower, but it's mid, something like that, because it runs in process and you can mock stuff. That means that we need to be close to the code. That means developers write these things. I can learn that APIs plus the logic that I have testing is working. So it's like an integration test, but without all the things that are running. It's not a real web server that will run. It may or may not talk to a database. Spring stable. It focuses on what's important to me, that the APIs call the logic correctly and does what I need them to do. So it's not a real API test, but it's something that when it breaks is highly debuggable. And that's very important to have. Okay, so same thing I can do from the outside. Now we're just moving outside the server itself, and we can use Postman, for example. Looks like this. So if I'm calling the same API, this time I have to specify server and port and specify a body, and I get the result, and I can actually look at write tests for that using Postman, what was the status, that the result was 3, and this is similar to what we have in the Spring. But once we step outside the system, we may not be able to look inside it back. And this is very important because, especially when you're talking about Postman, it can't go outside its sandbox. So the only way it can look into, for example, the database is if you expose the database through a server, and the server needs to run when you're actually running the test. So otherwise it will break. So whenever we're stepping outside, if I run this, by the way, right now, my server is not running, it will fail. And that means that in order for the test to pass, server needs to be running. Somebody needs to set it up. Somebody needs to kill it. Somebody is usually me. And the moment we step outside the process, we have more work to do. It becomes more complex. So something like Postman API tests are slower. We need systems to raise and move. Usually, something like this is written by testers, QA, people with less automation experience, and that's cool as well. There's a problem with Postman about this. Postman is not an IDE, and I saw like sometimes people write libraries inside it, which is it was not meant for that. It's hard to edit and debug and stuff like that. It's hardly easy. It's impossible to debug. You just log a lot of stuff. What do you learn when you run an API test from the beginning to the end? That the whole thing works. Of course, if something breaks in the middle, you don't know what. Therefore, it's very easy to break it. If everything runs on the same box, stability is bigger. If it runs on multiple containers from the API and afterwards, it becomes more fragile. And it's in terms of debuggability, we're now stepping into remote debugging and a lot of logs. It's hard to synchronize this stuff. And remote debugging is a set of skills by itself. So not saying that if you're the master of remote debugging, good for you. I was once that like myself. But it takes a lot of time. It's not the best thing to do with my time to do that. Usually use this kind of test when everything else is working correctly. The same thing we can do as a coded test. So the Postman is usually used for it's very visual. You can write a lot of things in it, and a subset of JavaScript to run the tests. But you can do a lot more if you write coded API tests. I'll show you an example in Java in Rest Assured. You can do that of course in any language and everything. This does the same thing. Rest Assured is library that you can set everything, header, posts. This time, remember, I need to set up the whole server and this will fail because it doesn't run. I need to run it before this thing happens. So more work and it's more fragile, but the same thing I can do. The cool thing about this, though, and opposite to what Postman, for example, does, is that this is code, so I can do whatever I want here. So if I want to check the database, have access to the database and don't have the limitation of Postman, for example, I can go there and with the right permissions, check that my post database actually changes something over there. So we're still slow, but developers actually write it. They're more, usually it's in their own project and it makes sense to do that. Still test the same paths for API to the end or whatever end we decide about it. Still fragile because we're still running the same thing, but it's easier to debug because this is closer to the code than before. Okay, jumping to front-end land now, which is another kind of test. So a lot of today you don't write plain vanilla pages or JavaScript. You write components, either React, Angular, Vue, and these come accompanied with testing libraries. Angular comes with its own test bed, but you have a React testing library and stuff like that for every framework there is. And what it actually does is based on, I'll speak React language for a minute, but it's true for every component. You kind of write this kind of component which translates into HTML and JavaScript. So the test bed, Angular or testing library, whatever, the test framework that actually runs this could be a test framework. I'll show you something in Jest, which runs React testing library, which renders a component, which checks if it was translated correctly here. So this is a bit differently than the test that we did. We're checking like functionality and interaction, but in isolation from a whole page. So it's like unit testing. Let me show you. So this is a component test for the same calculator that we saw. Basically, what you see here is getting text boxes and the buttons and basically typing into the boxes and clicking buttons. And what's interesting here is that in React, you can send events. If you're testing a component, it doesn't interact with the entire page. So you want to see that it interacts correctly with the right thing. So you mock the event handler. So you can catch the event by yourself. So this is interesting in terms of I don't need the entire page. I don't need other components. It could be slower to do that. I can write this thing. And I can actually do that for the entire page as well. So, because in React, a page is a component as well. This obviously fails. It doesn't run right now. Let's get back to my slides. So what do we learn from this? Yeah, this one. So it's slow. First of all, this is like a very small project and it's still slow. So until everything runs and so on, it's slow. Who writes this? This is the developers. The people who are writing, developing the components know how to test it. They don't have somebody outside the development area will not know how to this works. And what are the boundaries? What are with testing? What do we learn? That the component code translates correctly to an HTML DOM plus JavaScript that will give us the interaction that we actually want. Sometimes it's more. If our component goes to a database, it becomes a bit more than just a unit test, but you probably don't want that. You can if you're testing like SSR and stuff like that, but put that aside. If you want to do that, though, database needs to run, set up, have the same data that we actually need, and run it against. It's mostly stable. It's mostly like a unit test. So it's highly debuggable. You can put breakpoints in. It's the same process and runs to the same cycles that we know as unit tests. When we're talking about web tests, for example, another path, then our system becomes a lot larger. So we're talking about the test framework. I'll show you an example in Playwright, which runs a driver, which drives the browser, which loads a page, which now has HTML and JavaScript in it, and may talk to a server because otherwise it's not that interesting to do. So all this may look a bit similar. Let me just go to VS Code. And I'll show you an example in Playwright, which does the same thing, really, finding buttons and text box and stuff like that, expects all kinds of assert and so on. But this is the concept of the page and running entire system. And this may or may not run depending of the different components in the system. So let's go back to my slides. So this is like a bigger test, even slower. Who writes it? Playwright, for example, is JavaScript. You need some kind of automation if you're working with Selenium, Cypress, stuff like that, depending on the skills that you have. But this is outside the code. This is like, again, it's like API. We're running something else that runs the application. We're learning that the UI to whatever end it is actually works or not. If it fails, we don't know what happened. We need to dig in. Every component in there can break the test, timing issues and stuff like that, connectivity. Of course, Playwright's better than handling issues and timeouts, stuff like that, in terms of internally handling that. But this can still break because of timeouts and connection, stuff like that. How debuggable it is? Very low. If something like that fails, it's hard to know what happens. It becomes a skill by itself. We can take this thing to also desktop app tests, which not many people will do these days. Most of it is run by browsers, but test frameworks really operate the operation system, send Windows messages and stuff like that, and application talks to the server. Mobile apps go through different paths, but again, different components. This is a path that runs an emulator, like test framework runs Appium, for example, which talks to an emulator, which loads the application, which talks to the server. And if we're talking about having real devices that talk to the server, it's even harder to do. It's not possible, but not impossible, but it is possible to do. It becomes a lot more complex. So the same ideas go here. Slow feedback. Who can write this? Anyone that have the skills for that. We're talking outside the system, so it could be somebody that from the developers, the testers, automation, whatever. We're checking like end-to-end stuff, and it can be broken very easily by the different components. It's very hard to know what actually happened because we're looking at the system from the outside. So I threw a lot of different test things at you, and I want to get back to the point at where we started it. The first slide I talked about how to pick how to write the test. And the first thing to know is that we have a lot of options for the same thing that is interesting for us, but we get different benefits and different problems by picking the right or writer test for the job. So first of all, you need to understand that there are options, and you can replace different things. Sometimes you don't want to replace different types. Sometimes you want different test types to go through the same functionality, because when you look at it from different sides and one of the test passes, one of them doesn't, you learn what is working and what is not. So redundancy is not a bad thing. It takes time to have this redundancy though. Oh, overlapping is good. You need to know which kind of person has the skills to write the test that you actually want. Things that are working, you just checking your code would be probably smaller things. Things that testing longer paths give you better confidence when they're passing, but will break, and maybe you want either smaller or you go for the big ones, which is okay, but know the price that you're actually going to pay. So you need to pick the right tools for the job, the right test for the job. And this thing is called the best test, and there is no best test, but there are choices and there are options that we can pick from, and we need to know that we can actually do that. And it's not like the closest thing to what I have is what I'll go with, or everybody's here is just working with end-to-end tests, so this is what I'll do. No, there are options. We need to know what impacts the work and how it impacts the life cycle of the test afterwards. And when we do that, we kind of at least have some kind of better odds at the gambling that we do when we write tests, because we're probably going to benefit from that after a while. And this is what I wanted to share with you today. So first of all, thanks for coming. And I hope this was valuable for you. If you have questions, please put them at the Q&A box so I can answer them. If you want to follow me, ping me or do other things. Different ways to do here. Apart from webinars, I do also short videos, which go in usually weekly on YouTube, on Testing Guild channel. Thank you for everyone who came here today. See you in the next webinar. Bye-bye.